Now you have understood the different terminologies in the basic. The next term which I wanted to talk about is called favorable events. Favorable events or favorite events. Favorable events are where we are interested, like what we are interested to know. For example, if I my favorable event would be that if I'm interested in getting head or tail, then my favorable events would be that that head is, like, how many times head is coming or how many times tail is coming. In our previous example, if we are interested in identifying how many seeds are not getting germinated, this is my favorable event, right? And if we are interested in germination of the seeds, so for example, if I say if you throw 10 seeds in the soil, like 7 of them will not germinate it, right? So the favorable event is that non-germination of the seed, right? However, if I say 3 seeds gets germinated, which means my favorable event is that how many seeds I'm interested in getting germinated, right? So I'll say like 3 events will get germinated is my favorable events in that, right? So there's very minute difference between like the normal event and the favorable events, and like it depends upon what exactly we wanted to know, right? Similarly, we have mutually exclusive events, right? Now, the definition of this mutually exclusive events is the events are said to be mutually exclusive or incompatible if the happening of any one of the event excludes or precludes the happening of the other. If no 2 or more events can happen simultaneously in the same trial, then we call them as mutually exclusive events. For example, in our previous example, which we take like seed germination, right? In the seed germination, the seed may either germinate or it will not germinate. Non-germination will be mutually exclusive events. So mutually exclusive and exhaustive events are they have got a little different approach, right? So mutually exclusive says that if you get head, then you will not get tail, okay? If you get 6, then you'll not get 5, or if you get 5, you'll not get 4 or 6 for that matter, right? However, mutually exhaustive events means that at least one will appear for sure, okay? Right? Now this is little difficult to understand, so I just like to make you understand. For example, over here, say if I roll a dice, right? I'll get 1 or I'll get 2 or I'll get 3 or 4 or 5 or 6. My mutually exhaustive event will say, and this is my sample space, right? This is, I'll denote it with S. This is S is my sample space, which means all possible event will be here, right? My exhaustive event says that if I perform an experiment, either I'll get 1, 2, 3, 4 or 5 or 6, right? Either of the thing will definitely appear, right? However, what is mutually exhaustive event says that if 6 will appear, right, 5, 4, 3, 2, 1, they will not appear. So either this will appear, they will not appear, either this will appear, these people will not appear, and so on and so forth, right? Now there's a very minute difference between this mutually exclusive and exhaustive, right? So over here, either I'll get, say in the seed germination process, I'll get 0 germination, or I'll get 1 germination, 2 germination, 3 germination, 4 germination, or all 5. So my mutually exhaustive event says, or exhaustive event says, then one must occur out of all these things, okay? So if I say my experiment is mutually exhaustive events, so there is no possibility of right, no possibility of event not happening. In no conditions, it's not possible that event not happening, right? I'll just give you some examples where events are even not happening, okay? So we'll just talk about that. For example, So this is, so one must occur is my mutually it's exhaustive events, and mutually exclusive events are that if this is happening, nothing else will happen, right? For example, I'll just take another example. Suppose I am recording the delay of the train on station. Okay, so what exactly are possibilities? That if I say if the train is on time, I'll write 0 delay, right? If the train is 1 minute late, I'll write 1 minute delay, and so on and so forth. Okay, so what exactly will happen? Either I'll get 0, or I'll get 1, or I'll get 2. I'll just consider that the train is either 0 minute late, or 1 minute late, or 2 minute late. I know there are like 90 seconds delay or something of that sort, but just consider for that matter, right? Over here 3, 4, 5, and it may go up to say 100 minutes or even 200 minutes, or right, there could be n number of times over here, right? This is, now if I say train is 4 minute delayed, then you cannot say that train is 3 minute delayed also, right? None of these events can happen simultaneously. Only one event will happen. This is called mutually exclusive event, right? So this event is mutually exclusive, but is it exhaustive event also? No, it's not exhaustive. No, not exhaustive. Why? Because the train may get cancelled also, right? So if the train may get cancelled also, then there could be a probability that this event is not even happening, right? So the chances of you recording this event will be equal to 0 only, right? So the problem over here is that I cannot say that not every event will happen for sure, right? It may happen or may not happen. Okay, so this is something called as mutually exhaustive events. Okay, I hope you're getting this point. All right, let's move next towards the something called as equally likely event, right? What is that equally likely events? Outcome of a trial are said to be equally likely if, taking it to consideration all the relevant evidences, there is no reason to expect one in preference to others, right? Or two or more events are said to be equally likely if each of one has an equal chance of occurring, right? For example, if I have, say, if I'm talking about a dice, or just take an example of a coin, right? If you toss, probably you get head or you get tail, right? The chances of getting head or tail are equal chances. Now if you get equal chances of getting head or tail, this coin is called as fair coin, where the chances of you getting head and tail are all equal. Similarly, if you talk about a dice, right, chances of you getting 1, 2, 3, 4 or 5 or even 6, they are all equal, right? And if they are all equal, then you may call it as it's a fair dice. First thing first, it's a fair dice, and then these are all equally likely events. So the probability of you getting 1 is equal to probability of you getting 2 is equal to probability of you getting 3 is equals to probability of 4, and so on and so forth until probability of 6. Okay, so these are all equal events, right? So probability of you getting any one of the number is all equal, and that's where you call it as equally likely events. I hope you're getting this point. Okay, now in the next video I'm going to talk about the independent events and dependent events. I want you to stay tuned with me so that we can understand more on this. I'll see you next.